This is the beginning of part 3 of our module on interest rate forwards and swaps. We remind you that this part 3 contains chapters 3 and 4 of the module, with chapter 3 addressing cross-currency swaps and chapter 4 describing the process for revaluing an outstanding swap based on defined market movements, and also illustrating some uses of swaps for trading in interest rate markets. This chapter 3 teaches you to price a simple cross-currency swap using many of the same principles as for an interest rate swap. We begin by showing the process of pricing a basic cross-currency swap using the two curves in the two currencies for LIBOR and their respective discount factors, and then introduce some alternative pricing methods that are perhaps more common in certain markets. We will not spend as much time customizing various cross-currency swaps as we did in the previous chapter, since the principles are quite similar. We begin by illustrating a typical use of a cross-currency swap. Suppose you have issued a $150 million 3-year 5.5% bond, but really needed sterling to fund an expansion in the UK, which is expected to generate solid, predictable sterling revenues for many years. You were unable to issue the bond directly in the UK sterling market due to a lack of track record or history for your company in that country. And this has left you with a huge currency mismatch between the sterling revenues that will be generated through your UK expansion and the US dollar liability you undertook to fund it. You therefore convert the US dollar proceeds of your issuance into GBP, sterling, in the FX spot market, and seek to hedge your future US dollar coupon and principal obligations into sterling by buying dollars and selling sterling under a series of derivative contracts. You could, of course, use normal outright FX forwards for this purpose, but you would then end up with an uneven pattern of cash outflows in sterling, since the outright forward rates for successive payment dates will not be equal. There is nothing economically wrong with this approach, but the synthetic sterling liability you would end up with would have very uneven cash flows for the coupon payments, as well as a final payment in sterling at maturity that is quite different in size from the initial proceeds of the bond. What you would like is to have your bank make, or rather provide you with the cash flows to enable you to make, all payments required in dollars under the bond in return for you making to the bank, usually on the same dates, payments in sterling whose profile is identical to that of a sterling bond issue. Worksheet CCS for cross-currency swap shows how this is done. This worksheet begins by providing the 3-month LIBOR curves in US dollars and in sterling in columns C and H, and also the related discount factors in both currencies in columns D and I. The FX spot rate is assumed as before to be 1.5, and the day count convention under both swap legs is 3360 to make calculations easier. Note very importantly that the day count conventions under the swap payments is a different thing from the day count convention used to derive the discount factors from the two LIBOR curves, where we have used the correct conventions of actual 360 for dollars and actual 365 for sterling. You should click pause until you are certain you have fully understood this important technical point. The dollar LIBOR curve shown here is exactly the same as before, while the one for sterling LIBOR has been set to be inverted in a linear fashion. You can, of course, reset it to have any shape you would like. The worksheet proceeds by setting two streams of cash flows in columns E and J, in the two respective currencies, then calculating their PVs in columns F and K, and then the sum of their PVs in cells F18 and K18, and finally, after converting the sterling total into dollars in cell K19, calculating the US dollar difference between those two numbers, right here in cell F23. Go through this as slowly as you need on your own copy of the worksheet until you are absolutely clear of what has been done. Note also, very importantly, that cell J16 is designed to include for the sterling leg a repayment of principal of 100 million sterling at maturity, in addition to the last coupon of 1 million sterling. This amount of repayment of principal is set to equal the sterling amount originally obtained by the borrower when the borrower converted the $150 million proceeds of his bond into sterling at the spot rate. It is completely normal to do this under a cross-currency swap, since the intent is to replicate synthetically the cash flows of a real bond that would have been issued in sterling. You should realize, nonetheless, that the implication of this is that the exchange of principal at maturity does not have a zero present value, since the 3-year forward FX rate for that date would not be equal to the spot rate. What matters is to ensure that the sum of the PVs of the two sets of cash flows, i.e., the number appearing in cell F18 and the one appearing in cell K19, those two numbers are the ones that need to be equal, not the PV of any pair of individual cash flows in column F and column K. Now you will see that we have set the US dollar interest rate in cell D20 to equal that under the bond, i.e. 5.5%, and that we have set in cell I20, somewhat randomly, a guess of 4%, realizing that that may be too low given where the LIBOR forwards on average in sterling appear to range, and observe that the US dollar present value difference in cell F23 is $2.77 million. So now we use GoalSeek pretty much in the same way as before to calculate the correct sterling rate. Thus, tools, GoalSeek, please set cell F23 equal to value 0 by changing the 4% appearing in cell I20. Hit OK, and the sterling rate is now confirmed at 4.66% in cell I20. This is the all-in cost to the borrower of the synthetic sterling funded he requested. The diagram beginning on the slide is the traditional way of depicting a cross-currency swap in the context we just illustrated, where it is important to show the notional amounts in the two currencies being exchanged at maturity to remind your customer of this important difference as compared to simple interest rate swaps, and also to make clear that the coupons in each currency are calculated by reference to the respective notional in that same currency. Note that we have assumed semi-annual exchanges of coupons, but obviously this need not be the case, and normally that frequency would be set at least on the dollar leg to match the frequency of coupon payments under the bond you have issued, which appears on the left-hand side. One interesting point to note carefully when pricing a cross-currency swap is that you cannot simply add or subtract equal numbers of basis points to each leg after you have finished pricing the swap according to Excel or any other software. Suppose, in other words, that after you priced the previous swap, it turned out that the dollar bond could not be issued at 5.5%, but rather at 5.75%, perhaps on account of a last-minute deterioration in the capital markets. The client would logically ask you now to reset the dollar leg of the swap to this new higher level of 575, and would understand that the sterling leg also would need to be revised upward. But neither of you should assume that an identical adjustment of 25 basis points to the sterling leg would be correct, since what matters is the present value of these adjustments, and these present values would be obtained by discounting off two different curves. You can verify this on worksheet BPS conversion, where the dollar leg has been reset to 5.75%, and using GoalSeek to solve for the corresponding sterling leg reveals an answer of 6.88%, or only 22 basis points more than before. We have shown how you might price a cross-currency swap, but not really how it is hedged in reality. The most common approach is to construct a cross-currency swap by combining together three other swaps, all of which we have discussed previously in this module. The diagram you are about to see shows you how you might construct your hedge if you are trying to quote on the sterling-dollar cross-currency swap that your client has requested. You will enter into two IRS, one appearing at the top right in US dollars, and the other in sterling appearing at the bottom right. And in addition, you will enter into a LIBOR basis swap between the two currencies, remembering that this basis swap includes an exchange of the two notional amounts at maturity, which is what enables you to exchange notionals under the cross-currency swap with the company. Eliminating as many arrows on the right as we can, we see that the rate you would quote your client on the cross-currency swap is a function of the two IRS fixed rates and the adjustment to the sterling LIBOR leg under the basis swap. We should point out, with respect to the cross-currency swap, that it is possible, of course, to have the coupon on either or both legs floating rather than fixed. Suppose in our example that the borrower would prefer to create a synthetic sterling liability whose interest payments float by reference to sterling LIBOR. Quite simply, we would go back to the previous diagram and just remove the sterling interest rate swap from this diagram as shown here. Note that the removal of the sterling interest rate swap from the bottom right of this diagram, together of course with the cancellation of the offsetting dollar LIBOR payments, mean that the sterling LIBOR payments reappear in addition to the payment of the X basis points adjustment in this second arrow from the top on the right. It also goes without saying, finally, that the frequencies and day count conventions of the two legs of a cross-currency swap do not have to match. So we could have, for example, the dollar leg based on quarterly payments under a 3360 day count convention, while the sterling leg could be based on 6-month LIBOR under an actual 365 day count convention. This completes our discussion of cross-currency swaps.